Welcome to another great episode right here on IT Pro TV. I'm your host, Ronnie Wong, and today we're going to be taking a look at the PMP, the Project Management Professional. We're specifically going to get into the realm of forecasting. We've already taken a look at a little bit of forecasting, talking about a couple of different formulas, but that's when everything is going okay and you think that you can still rein it in. Sometimes, though, we need to actually go beyond that, and who better to help us than Mr. Don Pezet himself. How's it going, Don?
It's going great, Ronnie. Ready to jump right back into the world of forecasting. And if you haven't watched the last episode, definitely check out our part one. This is part two to forecasting. And in that episode, we talked about some interesting formulas. We saw estimate to complete, and we did a to complete performance index, a TCPI. And while we were doing the TCPI, I mentioned a new value. I mentioned EAC, right? The estimate at completion. And EAC is an important one because it's estimating what you think your total budget is going to be when an activity completes or when your whole project completes. So that's important, but we hadn't really looked at the formulas yet. In this episode, we're going to look at those formulas. And notice how I'm saying those formulas. EAC is a tricky one. There is one formula for EAC, and we're going to see that. But, like Ronnie said, if things aren't going right, there's all sorts of conditions that can change and your EAC number becomes garbage. And so there's actually 3 variations of EAC that we can run through. And so at the end of the day, there's 4 different formulas. Now on the exam, if they just give you some numbers and tell you to calculate the EAC, then there really is just one formula you need to remember, the main formula for EAC. But if they start giving you a story, you know, one of those word problems where they start explaining a situation that's going in on the project, well, that's normally a hint to you saying this is a variation, and so you need to use one of those variations of EAC. So we're going to take a look at each one, but let's just start with straight up EAC and how it works. The formula itself for EAC, I've got it pulled up here. It's actually straightforward. It's basically saying if you want to estimate how much you're going to spend at completion, well, if your project is going exactly the way it's supposed to, then your EAC is simply going to equal your BAC, right? Your budget at completion, your BAC, that's what you plan to spend at completion. Your estimate at completion should be the same thing. We estimate we're going to finish at exactly what we plan, and that's that, right? You don't even need a formula for that if everything's going the way it's supposed to. But if you're not sure, if you don't know if things are going the way they're supposed to, you take your actual cost, so how much money have you spent so far, whatever that actual cost is, and you add to it what's called a bottom-up ETC. Now, we saw ETCs in the last episode, right? Estimate to complete. How much more money we need to spend to complete an activity, okay? Well, that estimate to complete can be pretty accurate. We saw that. It can be inaccurate, too, and so you have variations of ETC also. But it's normally pretty accurate. But what's a bottom-up ETC? Well, that means I have to go out to all of my task holders, all the people who are doing the work on my project, and I have to get an ETC from every one of them. And it's bottom up. I start at the base layer of that work breakdown structure, and I get my estimate to completes, and I move up to the next tier and up to the next tier, and I consolidate it all down to a milestone or a deliverable, and I say, here's the estimate to complete for this deliverable and this deliverable, and you add all that up to get your whole project, if that's the way you're going. Or you can do this on an individual activity. It's up to you how you want to measure that. But a bottom-up ETC is where you get an estimate to complete for every single activity that's ongoing right now in your project. If you've got a small project, that's no big deal. You just go and talk to a couple of people and you get the numbers. But if you've got a massive project involving thousands of people and numerous simultaneous tasks, this can be pretty hard data to get. So sometimes you're in a hurry and there's things that we can substitute out instead of this bottom-up ETC. But the basic formula, the most important one for you to remember, is that EAC equals your actual cost plus a bottom-up ETC for your project. So let's take a look at an example. Here I've got a project, right? And it says, you are becoming concerned that your project may finish over its $350,000 budget. So right there I've got a BAC, right? My budget at completion is $350,000. You have requested ETCs for all active tasks. I reached out to all my task workers and I said, give me your estimate to complete. We need to generate an EAC so that we can report it to the primary stakeholders. We need to let them know what our estimate to completion is going to be. Hopefully it matches our budget. And so we've got the ETCs for everything that's active. Now, if I was just doing this for a particular activity, that's all I'd need. But if I want the project as a whole, I need to remember that there's activities that have already completed. I don't need an ETC from somebody that's already completed. I don't need an estimate. I have the factual data. So I go and get my actual cost for that, right? So here's my project cost to date. And my budget for activities that haven't even started. I don't need an ETC for something that hasn't even started because I just use the plan, right? Whatever's in the plan is what I'm going to go with. So there's stuff outside of what's currently active. But here's the 4 activities for me that are currently active right now and their estimate to completes. So when I want to find out my EAC, my estimate at completion, I need to take my actual costs, right, what I've spent so far, and a bottom-up ETC from everybody else that's out there, and add them together, right? So my actual cost is $200,000, right? I've actually spent $200,000 at this point, right? Then I need my bottom-up ETCs, my estimate to complete for everybody else. Well, I've got my estimates to complete right here, 7,000, 2,000, 24,000, 3,000. Now notice, they're not telling me what their costs are. I don't know their earned values or actual costs. Well, we've got project cost to date. That's my whole project. That would include the expenses that I've already spent on these activities. This is my ETC, what they're going to need past that, right? But what about this over here? Budget for activities that haven't even begun yet. Well, we count those as ETCs. Those are estimates to complete. It's not, they are estimates, right? We created them back in the plan. They haven't actually started, so I don't have to collect them. I just use the plan data, but it's right here. So I'm going to add up all of my ETCs and the budget for any activity that hasn't started. I'm going to treat those as ETCs, and that is how much more I think I'm going to have to spend to finish this project. And then I combine that with what I've already spent, and I'll have my estimate at completion, what I think that full expense is going to be. So if we work this out, the math starts to escape me, right? So our actual cost is easy. That's $200,000. We know what our actual cost is. But then I need to add my my ETCs, right? So my EAC is going to equal $200,000 plus all of these other ones summed up. So I'm going to break out my friendly calculator here, and we'll sum all these up. So
36,000, I believe.
Your math skills, Ronnie, far exceed mine. So let's just run this through a calculator, and we'll say 100,000, right? Because that's the budget for stuff I haven't even started yet. 7,000 for activity 1.1.7. We got 2,000 for activity 3.2. We've got 24,000 for activity 4.5, and 3,000 for activity 4.6. And you were right. So it is 136,000 is what my current ETC is. So I can punch that in here, $136,000. All right, remember the 100,000 coming from here and 36,000 from the ETCs from what I got open. Well, if I add those together, I end up with a nice, cool $336,000. Now my fear was that we were going to exceed my $350,000 budget. Now that I've seen this, we're going to come in under budget. Now I get an all-new fear of what work hasn't been done that was supposed to be done. Why are we ahead like this? Who knows? Maybe I had $14,000 in reserves baked into the project or something. I don't know. If you've padded your numbers, which is bad, you shouldn't do that. But maybe that explains it. We need to go and find out why. But the point is, I now have an estimate to complete for my project, and I'm showing I'm in pretty good shape. I'm going to be under budget, right? That's what an EAC can do, and it's pretty common sense, right? We're just taking the numbers that we've got, the numbers that we know are fact, and then we're factoring in estimates, either estimates that people are giving us right now or estimates that we came up with back in the project plan. And we're combining that all together to create that final estimate of where we're going to end up. And here, my EAC is $336,000. Now, I did this for the whole project, right? If I just did a single activity, like if I took activity 1.1.7, I could go and find the actual cost for 1.1.7, and I could add the ETC for 1.1.7, and then I would have the EAC just for 1.1.7, right? So you can calculate it on a single activity if you want, and you get that EAC for it. And you might need that when you're running some of the other formulas that are out there, right? But usually we do it for a project as a whole. And the real challenge with this is simply getting the data, getting an estimate to complete for everybody. So imagine going to all of the people who are in the field, who are actually doing the work, all the contractors or whoever, and saying, I need that estimate to complete for what you're doing. How much more money do you think you're going to spend, right? And calculate it out as dollars like this, because they got to factor in hours and all that. It's really earned value. So calculate that out and turn it back into me. It's a lot of burden. It's a lot of effort. So we don't like to pull this if we don't have to, and that's why we have some of our other variations of this. All right, so let's take a look at one of those variations. The first variation is this guy right here. Okay. Now notice what we're doing. Instead of doing actual cost plus a bottom-up ETC, here it's actual cost plus budget at completion minus earned value. All right, what's going on here? Well, we're swapping out the ETC, the bottom-up ETC. We're taking that out and replacing that with our budget at completion, so what we plan to spend, minus our earned value, which is what we've spent in terms of effort so far, right? And earned value is more accurate than AC in this case because it's taking into account schedule, right, where AC doesn't take into account schedule. So we're going to factor that in and determine what's left, right? What's left for us to spend. So we end up with a number that's not necessarily as accurate as what we would have gotten a moment ago, right? When you get those ETCs from the field, these are the people that are actually doing the work. And they've got a good idea of how things are going and how much more they're going to need, right? Versus this variation that's using a plan we came up with potentially years ago that isn't taking into account what's actually going on in the field. So it's less accurate. But then it brings in earned value. Earned value is calculated on what's actually happening, so that makes it a little more accurate again, okay? The end result is you end up with an EAC that is pretty close to where you'd expect to be, right? That is pretty close to where you think you would be at on this anyway. And it's usually good enough. I hate saying that, right? It's good enough. This is normally the one that I start with, right? I don't necessarily want to go and get an ETC from everybody in the field. I don't want to burden them with that. They've got their own work to do. They're already giving me status reports. I have to be in a real situation to go and say, all right, it's time to go out and get those ETCs. So with this one, we can use it when we've got good data. If we already have our actual cost from accounting, if we already have our budget at completion from our plan, which you certainly should have, if we've already got our earned values from status reports, we can take the data we already have and get results that are very close to what we would get with a full bottom-up ETC. So this is faster. It reduces the effort of getting ETCs. And so I'll normally start with this one and see the numbers I get. And if I'm not happy with the numbers, then I go out and say, all right, guys, we need to shore things up. Everybody turn in an ETC. I need it by Friday, right? And then we get that number that is now as accurate as it's going to get, and we start to act on it. But if these numbers come back good, then I don't belabor the point. I'm not going to go and request an ETC from everybody when the numbers are looking good, right? So the first variation is just sacrificing a little bit of accuracy in exchange for being able to reuse data that you normally already have from your typical status reports, right? So an example of this might be, like here, we want to get a ballpark EAC for our project, but we don't want to waste team resources collecting ETCs from the task workers. Our project budget is $250,000, that's our BAC, and our expenses to date are $175,000. That's going to be our AC, right, our actual cost. The EVs from your incoming status reports add up to $160,000. So we've totaled up the earned value from all of our various activities at $160,000. What is our EAC? Well, if we plug all that in, right, our EAC is going to equal our actual cost, so $175,000, plus our budget at completion, which is $250,000, minus our earned value, which is $160,000. Now, I already know I've got a problem here, right? Because my earned value adds up to $160,000, but my current expenses are $175,000. So it doesn't take a wizard to figure out this project's got some issues. But when we calculate our estimate at completion, we should see that things aren't painting the greatest picture for us, right? So let me just come in here and plug this in. So if I take $175,000 and I add $250,000, and then I subtract $160,000, I end up with $265,000, right? So $265,000. My budget is $250,000. My estimate at completion is $265,000, right? I'm going to be $15,000 over budget. Is that good math, Ronnie?
It is.
Okay. I saw you squinting your eyes. I was like, oh shoot, I screwed something up.
It's me and 200,000. I saw 200,000, not 250.
Oh, okay. All right. So I'm going to end up $15,000 over budget, right? That's what this estimate shows me. And so that's a problem. $15,000 is a lot of money. So especially in the general scheme of this project here, that's a good, it's not 10%, it's, what does that end up being, like 7% or something. So still a pretty good chunk, right? So I want to go in and take corrective action. And this might be the point where I say, you know what, time to go collect some ETCs. Right? Because when I have the ETCs, I can figure out exactly who the problem is. Or honestly, I can just go and look at my schedule or cost variance and find out there too. There's a few different ways we can go and isolate the problem. But as a whole, I can see that my project's not in the greatest shape. It's not the healthiest project in the world. So definitely something I'll want to act on. but it didn't require me going out and getting a bunch of ETCs to do it. So that's the first variation. And on the exam, what you're going to see are questions that ask you to calculate an EAC, and they're going to give you values. And you've got to look at the values they give you and make do with it, right? So the questions will read like mine did, where they feed you data and you have to calculate an EAC. Well, you got 4 different formulas for EAC, so you look at the data, but sometimes they give you more than you need. And so you've got to interpret the question to figure out the right formula. And sometimes they don't give you enough, and so they usually put that answer on there, not enough information provided. And don't be scared to choose that. It is right sometimes. And so if they just didn't give you enough information for any of the formulas, or maybe they did give you enough information for one formula, but they put a statement in here like mine where it said, you don't want to waste resources by collecting ETCs from the team, right? But maybe they give me enough information that includes ETCs or something. You know, I guess that wouldn't make a whole lot of sense. But if they did that, I still wouldn't want to use that formula because they told me not to do it, right? So we just have to make sure we interpret that question properly. All right, so that's variation number 1. That one pretty much makes sense. Let's take a look at variation number 2. Variation number 2 gets a little stranger. And you know, each of these variations has a name, right? The first variation, it's actually called EAC forecast for ETC work performed at the budgeted rate, right? And what they're saying here is instead of work performed with a estimate to complete, right, it's the estimate to complete being calculated off of the budgeted rate. That's what we did, that budget at completion minus EV. So that's the name of that one. Variation 2 is EAC forecast for ETC work performed at the present CPI, right? So instead of using the budgeted rate, we're using the cost performance index, right? We've got this index that indicates how we're doing in terms of cost. We can just use that to calculate out what our EAC is going to be. This is even less accurate than variation 1 though. And so this one, on each of these, I kind of put like when you would use it, right? On the other one, I said the big advantage is that you would use it when you had good data and you didn't want to bother everybody with ETCs. This one, variation 2, when would you use it? When you're in a hurry. Yeah. If you're in a hurry, if you just need a quick and dirty number, this is the guy for you, right? You use this formula. It's simple. Your budget at completion divided by your CPI, and that'll give you your estimate at completion. If your CPI is 1, if you are perfectly on budget, right, then your budget at completion divided by 1 is just your budget at completion. Your estimate at completion now equals your budget at completion. You are perfect. But if your CPI is 1.1 or your CPI is 0.90, right, when you divide your budget at completion by that, you're going to get a different number. And it's not going to be incredibly accurate, but it's good enough to let you know whether you're in trouble or whether you're within that small window where it's acceptable to vary, right? So we use this if we're in a hurry. And typically this one is not used in any reports to give to people. It's just used for you to get a quick view of the project and determine whether or not you need to go more in depth, right? So this one is definitely when you're in a hurry. But you'll see you can calculate EAC with just 2 values, your budget at completion and your cumulative CPI, right? The CPI for all of the work to date, not just that one reporting period. So as an example, let's say that I've got a project like this and they're telling me we've been making changes to bring our project back in line. All right, so we had a project that was off, right, in our first example. And so we've taken that first project and we made some changes to try and bring it back, right? Remember in the first example, we were off by $15,000. So we've made some changes. Hopefully it's coming back in line, all right? We want to figure out the effectiveness of our change. We just want to see if we can get it better, you know, if we've actually made the improvements we need. So we run some numbers, and our current cumulative CPI is 0.96, all right? So if we're at a 0.96, what's our new estimate at completion? Well, if I was using my old formula, I would need my earned values and my actual cost and all that. But I don't necessarily have that here, and I'm just in a hurry. So I'm going to take the numbers I've got, and I'm going to say that my EAC is going to equal my budget at completion, which is $250,000, right? That was from the first example. And I'm going to divide that by my current CPI, which is 0.96. Okay, so I made some changes. My CPI is now 0.96, and we run that through our formula. 250,000 divided by 0.96, and I get $260,417, right? So that's going to equal 260,000 and $417. We'll get it sooner or later. There we go. All right. So now we're at 200, and my touchpad's going crazy. We're at $260,000. Okay. So when I ran it before, we were at $265,000. we made some changes to try and improve things. And when I ran my quick formula, we got 260,000. So we did go from 265 down to 260, right? So I'm a little bit back in line, but I'm still not perfect, right? I'm still off by $10,000. So we have made an improvement, but it's not necessarily enough. So we continue making more improvements. Now, because we're using cumulative CPI, improvements don't necessarily show up right away. And when we covered ETC, I kind of talked about that a little bit, that sometimes you might want to throw out your CPI because it's cumulative for the whole thing to date. So the bad times are still reported in your CPI. And so this formula might not be the most accurate in that scenario. It's very hard to see those changes. But if that's all the information we have, at least we can get a ballpark, and then we can go and act upon that and maybe get more detailed information or whatever. So that's two variations of the formula. There's one more that I want to show you guys, and this one is interesting because, you know, the other two, one of them used CPI, right, or we used our budget and our plan, but they really focused on cost, and really estimate at completion is about cost. Most people care about how much more money they need to spend, but we haven't really been taking schedule into account. They all use earned value, and earned value involves scheduling, so there is some of that. But the third variation brings in scheduling, and the reason it does it is when you've got a project that's in trouble, you've got your triple constraints, right? You've got your quality or your requirements, you've got your cost or your budget, and you've got your schedule or your time, right? So cost, time, quality, those are the three big constraints that we deal with. And when you have a problem, you can normally fix it by either increasing your cost or decreasing your quality, increasing your schedule, whatever, right? And when you adjust one, it adjusts the other. And so sometimes it's not so much the cost that's the problem as it is the schedule. And with each of the ones we've been looking at, we really haven't accounted for that. We've said we got a problem, we'll figure out how to fix it later, we just need to identify that we have a problem. But what if you've got a project sponsor that comes in and says, look, this is the date you're going to finish. When we planned this project, you said you were going to be done January 1st, you're going to be done January 1st. Well, if you're in that scenario where your project dates are kind of fixed, you want to hold that project date, you've got to factor schedule into this because you're not going to change it. The schedule's not going to change, so it's got to be a bigger part of the formula. And so we can take the formulas that we've seen and adjust them just a little bit, right? So here's the third variation. And with this one, you'll notice the big difference is that we're bringing in a cumulative SPI, right? What we saw a moment ago was budget at completion divided by CPI, or cumulative CPI. But here, we're going back to the old formula, the actual cost plus the budget at completion minus earned value, okay? So straightforward formula right there. Not the original, right? The original formula was actual cost plus bottom-up ETC, right? That's the real formula for EAC, that original one. But the first variation we saw was EAC equals AC plus BAC minus EV. And the difference here is we're dividing that by our CPI, our cumulative CPI, times our cumulative SPI. All right. So our cost performance and our schedule performance index, we're factoring both of these in. And remember, if you've got an index that's at a 1, 1 times 1 is 1, and any number divided by 1 is just that number, and we end up right back at that formula, EAC equals AC plus BAC minus EV, right? But if your cost performance index is off, or your schedule performance index is off, then that's going to affect the ultimate EAC that this results in. So this one requires a little bit more data to be fed into it to get accurate results out of it, right? But if you're dealing with a fixed schedule, if you intend to hold to the current project schedule dates, then you're going to need to factor in SPI, all right? And that's really the only time we use this variation. Variation 3 is just when you got a hold of those dates. So in the word problem, if they tell you that, if the dates are not flexible, be thinking about this formula here. And this formula requires a lot of information, and so you've got to make sure all the information is in the question. Otherwise, you got to choose that not enough information provided. Now, I made a little note here. This formula only works when over budget, all right? What does that mean? Well, if you're under budget, right, if things are going well, your CPI multiplied by your SPI starts to skew things, and things can really start to get off, right? And then it doesn't work out quite right, your numbers get skewed, and it kind of breaks things. So if you're under budget, in other words, if things are going great for your project, then you don't need this formula. Don't, and you're probably not even calculating EACs at that point because you're under budget. But either way, this one doesn't work, right? So we need to make sure that our budget is bad, that we are over budget, and that's where this formula is going to come in, right? So let's see an example of that. This is the only formula we have that actually has that kind of contingency. All the other ones work no matter what. All right, so here we've got an example, and it says, changes to your project have been fairly effective at getting back in line with your budget of $250,000. However, further change is needed. Your project sponsor has indicated that she will not approve any further schedule changes. Adjust your EAC to account for the fixed schedule. Your current project SPI, your cumulative SPI, is 0.97. Right. This is the same project from the last two examples, so we've already got the other information, our actual cost, our BAC, our EV, our CPI, and our SPI. We can go and get those and kind of plug them in from the other side, right? So our EAC is going to equal our actual cost, right? Which I take a look at the last one, where was our actual cost? Here, $175,000. So I'll plug that in, $175,000. And I'm going to add to that my budgeted completion minus my earned value. And I can get both of those from the first one, where my budgeted completion was $250,000 and my earned value was $160,000, right? So let me just copy these. So we're just going to lift those right out of there, kind of cheat a little bit. There we go. And then I need to divide that by my CPI, my cumulative CPI, which was, I believe, 0.96, wasn't it? Let's go find out. 0.96, yep. Times 0.97, which is our SPI. Okay? So when I start to plug all that data in, I'm going to get my results. Now, my biggest challenge here is I've got some order of operations that I've got to execute here, right? The whole please my dear Aunt Sally kind of thing. And so I've got a series of parentheses here I've got to sort out. My budgeted completion minus my earned value, that needs to happen first. So I've got $250,000 minus $160,000, which is $90,000. All right. So we'll just change that to a quick $90,000. All right. And then I'm not even going to pretend to do 0.96 times 0.97 in my head. So let's just get the calculator on that one. 0.96 times 0.97 is 0.9312. All right. Now, normally I round these things, but that's a small enough number that I might just keep it 0.9132, I think is what I said, right? 9312. You always got to double check the math. You know, I'm terrible about that. All right, there. So now I've got a little bit simpler of a formula to handle, but notice that this portion has to be done first. If you get the order of operations out of order, then things really get messed up, right? So now I need to take this and do 90,000 divided by 0.9312, and I get $96,649, which I will round. 96,649. So this is just going to become 96,649. All right. I guess I don't really need these parentheses anymore. And then I can add that up, and I'll have my new EAC. So if I add $250,000 to, 175, let me subtract that back out. And so I'm going to add $175,000. Otherwise, my project will be way over budget. I get $271,641. $271,649. Right? Now, in the problem, it said changes to my project have been fairly effective at getting us back in line, but I can see that things are actually worse. Okay, now, how did that happen? Why did I think I was effective at getting back to 250, but things are actually worse? What the heck happened? The schedule happened. Okay, I'm behind schedule. If I'm behind schedule, then that's a problem. I need to be at or ahead of schedule. All right, but in this case, I'm not. I'm behind schedule. And so that makes this number go higher. So while my cost, my CPI is pretty close at 0.96, it's not 1. It's not perfect, right? And even though I'm making strides to get better, my schedule's still messed up. And when I factor that in, I get an EAC of 271. Things are not right. I need to fix my schedule. I need to get that back in line. And my schedule's not that bad. 0.97 is pretty close, right? But if you've got a fixed target date that you're working on, close is not good enough. And it starts to skew the formula. Combined with a budget that's not right, then it gets even worse. And so now you might have a project that looks like it's in good shape, or at least better than it was, and it turns out to not be in that good a shape. And now I've really got to pull in my resources and try and get this corrected. So factoring in SPI, it makes a difference. It really does, and it is important. So in my first example, we got an EAC of $265,000. Then we worked to fix it, and we saw where we got it down to $260,000. But when we factored in that schedule, back up even higher than we were in the very beginning, because we never calculated this in. And the reality is, if a fixed date was part of the equation, we should have been using this formula from the very beginning. We shouldn't have even wasted our time with the other formulas, because that schedule is so important. All right. Now, the original formula, way back, this guy, right? Because it's got bottom-up ETCs coming in from all the people out there in the field and stuff, this is taking into account things like schedule and our earned values and all that. And so this is the most reliable of all the formulas. And so this is the true formula for EAC. It's the one you want to use, assuming you can get those bottom-up ETCs. That's really important, right? But if you don't have that, that's where you've got the three variations. Just to run over the variations again, the first variation, EAC forecast for ETC work performed at the budgeted rate. This is one that we want to do if we want fairly accurate numbers, but we don't want to collect ETCs for everything. That we know the work is being performed at the budgeted rate, that we know things are kind of going as expected, and we use this and we get our numbers, and they're pretty accurate. All right. The next one was EAC forecast for ETC work performed at the present CPI. This is where we're just in a hurry. And so we take our CPI, our cumulative CPI, and we just apply it to the budget, and we get a number. This is not necessarily indicative of what's actually happening in the field, so this is a ballpark. We use it when we're in a hurry. And then number 3 was EAC forecast for ETC work considering both SPI and CPI factors. And this is the one that we use when we know we've got a schedule that has to be met, that we don't have flexibility there. It's not all about cost. Schedule needs to be factored into. So on the exam, when they ask you a question, it's going to be in the wording of the question which one you should be leaning towards. And if they don't give you any hints, then you either assume the default one, the original AC plus your bottom-up ETC, or you just look at the numbers they give you. Look at the numbers and see which one gives you enough numbers to run a formula, and that kind of give you a hint there too. All of these result in an EAC. It's just some are more accurate than others.
So Don, that's a great reminder for us to think about when we start taking a look at EAC. Remember that we're determining EAC to really help us when we know that that budget is not going to be complete, and yet we need to still figure out how much money we really do need to have on hand to make everything work as well. Those variations are going to come in handy when you have enough information to do them, but remember also on the exam, you may find out that you don't have enough information. It's a great reminder, and it's a valid answer as well. Don, any last words of advice for somebody saying, I think I'm ready, but this is a little bit more daunting than what we'd seen before in all the previous earned value estimates?
Practice. Practice. The more of these you work through, the better you'll get, and there will be word problems on the exam typically. So, interpreting the numbers. You can run through my examples that I gave you. I just made all these up. But there's practice exams that are out there that are really good. There's a lot of books out there that come with practice questions. On the IT Pro TV site, we use Transcender practice exams. You can do those. There's various other resources out there on the internet, but really practice. And if you're worried about getting the numbers right, use software like Microsoft Project. And you can just put in fake numbers in there, and then you can calculate these out by hand, and then you can let Project calculate out the numbers, and you can compare, right? And see which ones you get and kind of where those numbers stand and how accurate you were. So kind of a quick way to make up your own problems. But definitely practice, 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 because these are not formulas you're going to use every day. They might be formulas you never use ever because you have software that does it for you. So the exam may be one of the only times you have to do these by hand. You've got to prove that you understand how the formula works. That's what the exam really wants. They don't care if you know how to do math. They care that you know what the formula does. And so you've got to make sure you know those. And you got to memorize the formulas. I'll give that same piece of advice I gave earlier, which is at the beginning of the exam, take a few moments to write down your formulas on the piece of paper. That way when you get to the formula questions, you can just answer it, and it's not something you're having to rack your brain trying to remember the formula for.
Excellent words of advice when we're getting ready for that exam. Thank you again, Don, for the examples there. They really did help clarify a few of the little ins and outs that we may not think about. And thank you also for joining us today, too. Signing off for IT Pro TV, I'm Ronnie Wong.
And I'm Don Pezet.
And we'll see you next time.